Hello, brother sir. Hello.
நான் பேசுறது கொஞ்சம் கேட்கல உள்ள ஒரே ஒரு சார் நான் மொபைலில் எடுத்துகிட்டு பேசுகிறேன் அதில் கேட்கலாம் சார். ஹலோ ஆடிஃபுல்லாக
Hello. Is it audible, sir? Is it audible, sir?
Very good morning, all of the here. So, in the event for Department of Electrical and Electronics Engineering conducted the international conference on the recent challenges on electrical and electronic field. Today's agenda is the program started with the inaugural prayer, followed by the welcome address and the inaugural address in the president's city, and a keynote address will be delivered. The two distinguished professors are attached and will shortly join here. The first one is Dr. Arunkumar, Sangaiah, Distinguished Professor, International Graduate School of Artificial and Intelligence, National University of Science and Technology, Taiwan. Second professor is Dr.S. Malathi, Professor Department of Engineering College, Chennai. Students kindly wait in our online and offline modes. Will start our you all these interest in our department, the recent challenges to discipline. Before we get started, we would like to take a moment to share our appreciation for everyone linking up their schedules across the time zones in this way. It is my honor to welcome all the head of the department and our beloved principal and our head of the department and all the faculties in this auspicious event. As we begin this significant event, it is fitting way to start with a prayer, to guide us in this moment of reflection and seeking guidance. I would like to invite Please be seated. This is the time for welcome the online and offline members, dignitaries as well as. Now, I welcome our head of the department, Dr. Valliammai ma'am, for welcome the gathering.
Good morning, everyone present here. It fills me with immense pleasure to stand before you such a distinguished gathering for the inaugural of this international conference on recent challenges in electrical and electronics engineering. First of all, I would like to welcome our founder chairman, Reverend Father Dr. J. Arunkumar, whose wisdom will always lead us in all activities. I extend our warm welcome to our administrator, Reverend Sister Hamlet. Her visionary leadership and unwavering commitment play an important role in shaping the success and direction of our esteemed institution. We welcome you, sister. Then I extend a warm welcome to our principal, Dr. Arunkumar. His leadership has not only guided our college, but has also inspired countless of students, faculty, and staff members. We deeply appreciate your dedication and are so pleased to welcome you, sir. We extend a special warm welcome to our esteemed speakers, Dr. Arunkumar Sangaiah, Distinguished Professor, International Graduate School of Artificial Intelligence, National Yunlin University of Science and Technology, Taiwan, who is a leader, researcher, and academician with a remarkable track record, will be sharing her insights on revolutionizing green energy with the AI. On behalf of organizing team, I welcome you, sir. Next, I would like to welcome another speaker, Dr.S. Malathi, Professor, EEE Department, SRM Valliammai Engineering College. Her insights and expertise will undoubtedly enrich this forum. And I know that they will provide a valuable perspectives for all of us today. In this great moment, on behalf of our organizing team also, we welcome you, ma'am. In this time, we also acknowledge the tireless efforts of the organizing committee whose dedication has made this event possible. I welcome you all, my dear team members, to this great occasion. I welcome all the HODs, staff, participants from various places to make this event a grand success. Once again, I welcome you all. I wish you all an enriching conference once again. Thank you.
Thank you, ma'am, for your welcome. This is the time for the inaugural address. We are delighted to call our Associate Professor Dr. D. Srinivas for inaugural address.
So, good morning, one and all present here. It is my immense pleasure and privilege to welcome all the members who are present here physically as well as through online means. I welcome you all for this international conference titled the International Conference on Recent Challenges on Electrical and Electronics Engineering 2025, ICRCEEE'25, being conducted by the Department of Electrical and Electronics Engineering of JP College of Engineering. We are deeply associated. In fact, the head of the institution of our college, JP College of Engineering, is from our own department. So with that privilege and deeper concern that we have derived from our head of the institution, Dr. M. Rajkumar sir, it is because in skills and provide a larger platform, provide an equal opportunity for all the students of our department. So with this, he has guided us to initiate, given this initiative to deriving from the the head of the Department of Electrical and Electronics Engineering of our institution, who is the chair of this conference, international conference. Thank you, ma'am, Dr. V. Jalakshmi, ma'am. I also like to inform the students and all the gathering members, research scholars, academicians, technical delegates, to seek the guidance, seek the support, seek the clarifications from the technical concepts that are being discussed here in this international conference. We have very valuable, distinguished professors from two institutions, one from Taiwan and the other from Chennai. They are essentially the best that we can find in their corresponding domains. Sir is actually among 1% of the lately on a spectrum. We have received papers from not just electrical and electronics engineering. We have a wide variety of papers that renewable sources like wind and solar. Now these topics we are able to find it, more than 6 topics were based on these. And very interestingly, we have topics from shipping. Two of the papers we have received from MIT University, they are relevant to shipping applications. So the transmission and distribution challenges that they face, considering ship as a standalone load. Now, these are very interesting topics that institutions and students, so that you make use of this platform in the best possible way. I hope this international conference would pave the way for sharing our knowledge in similar such forthcoming events. Thank you so much for the opportunity. Thank you.
Thank you so much, sir, for your inaugural address. This is the most excited moment for release the proceedings of our international conference. So I kindly invite our principal, Dr. Arunkumar, for release the proceedings. So I humbly request the dignitaries on dais and off dais kindly accompany the principal. So in the conference on recent challenges, so first one is Dr.S. Malathi, the professor in the Department of EEE, working as a professor in Valliammai Engineering College, Chennai. The second keynote speaker, Dr. Arunkumar Sangaiah, distinguished professor of International Graduate School of Artificial Intelligence, National Yunlin University of Science and Technology, Taiwan. So before that, this is the time for invite our keynote speaker with their profile. So I request Dr. T. Arun Srinivas to deliver the keynote speaker with a profile.
Good morning once again. I would like to introduce the first keynote speaker, Dr. S. Malathi ma'am. Dr.S. Malathi ma'am, who is a professor from the Department of Electrical and Electronics of SRM Valliammai Engineering College, Katangulattur, Chennai. And her University, Chennai. And completed her research as well in Faculty of Electrical Engineering at College of Engineering, Anna University. Her area of interest includes smart grids, renewable energy systems, electric vehicles, e-vehicles. She has more than 23 years of teaching experience. She has filed three patents, and one of the patent has been granted, has received the grant successfully. She has authored textbooks on basic electrical and electronics engineering. She is a recognized Anna University supervisor, and she is presently guiding 5 scholars. So she has conducted 2 AICTE funded adult faculty development program. So with this few words about ma'am, I would like to welcome her for this international conference on recent challenges in the domain of electrical and electronics engineering. And I would like to add few more words about ma'am. So it is indeed a greater privilege and honor, indeed a greater support that we are seeking from you, ma'am. During very difficult and short duration of time, we have approached you, and sorry for the inconvenience caused, but still you have graciously accepted our invitation and to enlighten the minds of the younger generation who are waiting to get your presentation, ma'am. Thank you so much. I hand over the session to ma'am. Over to you, ma'am.
Thank you, sir. Thank you, Arun Srinivas, sir. Sir, am I audible, sir?
Ma'am, your voice is actually not audible.
Sir, is it audible, sir? Sir, is it audible, sir? Do I am audible? Sir, is it audible?
Yes, ma'am, it is audible. Kindly.
So may I proceed, sir?
Yes, ma'am.
Thank you. Respected P. Hamlet, Administrator of JP College of Engineering, Dr. M. Rajkumar, sir, the Principal of JP College of Engineering, Dr. V. Jayalakshmi, HOD EEE of JP College of Engineering, Dr. T. Srinivas, Associate Professor, R&D Coordinator of JP College of Engineering, and to our beloved students, research scholars, and my dear students, good morning to one and all present here. I am very happy to deliver the keynote address on this international conference on recent challenges on EEE. This topic is very nice because the wealth of the nation always depends upon the power demand of the country. And we peoples, that is our we peoples, that is the electrical and electronic peoples, are proud to be the main part in promoting the. I want to start my session with the quote said by Tim Booth. He said that energy is essential for development and sustainable energy is essential for sustainable development, and we have the major role in having the sustainable development. And another quote which is very important: the future is green energy, sustainability, renewable energy. So this is the one very important international conference also focusing on the recent challenges. The basics of the risk called as the energy sources. So I'm just going to say about a few words which is very basic. First, I want to say basic, then I will slowly propagate into the topic. The energy resources are used to generate electricity and other forms of power for human use. The growth of the nation, as I said, it largely depends upon the availability of energy resources. So let me say about the classification of energy sources. And you people, my dear students and faculties, we know that the classification of energy sources are mainly depends upon various aspects, and these are classified in various aspects. If we classify the energy sources depending upon the usability of energy source, we call it as a primary and secondary energy source. Depending upon the traditional usage, we classify into conventional, non-conventional. Depending upon the long-term availability of the sources, we can classify it into renewable and non-renewable. And commercial application, we can classify as commercial and non-commercial energy source. And depending upon the origin, we have fossil fuel, nuclear energy, hydro energy, solar energy, wind energy, biomass energy, geothermal energy, tidal energy, ocean thermal energy, and ocean wave energy. And thus, the renewable and non-renewable energy plays a prompt role, and here I want to discuss about this thing. Renewable, a few things about the renewable and non-renewable energy source. My dear students, you know well about this one, but anyway, I want to have a recall. These renewable and non-renewable energy sources are the energy resources that human society uses to function on a daily basis. The difference between these two things are nothing but the renewable energy sources can naturally replenish, whereas the non-renewable sources cannot replenish. Some drawbacks of non-renewable energy source nowadays, because we are very much aware that we should not we should avoid acquiring the energy from non-renewable energy source, because it reduces greenhouse effect, which affects the ozone layer. You know, people, we are very much aware about it. Its byproducts cause damage to the environment, and we have more care to safeguard our environment. Once it is exhausted, they cannot easily be replenished. Rising cost is more. Residual products are non-biodegradable, which is polluting the atmosphere and earth. Its products pose potential threat to human health, responsible for acid rain. So in this aspect, this non-renewable utilization of non-renewable energy sources is greatly avoided. Some examples for non-renewable energy sources are fossil fuels, crude oil, and you know well about this one, but anyway, I won't have a glance, and slowly I'm propagating to my title: coal, uranium, natural gas, tar sand, steel, phosphate, aluminium, ground waste, and oil. And advantages of renewable energy source. Why we peoples and the governments and the researchers and scientists are stressing more about the utilization of renewable energy sources, because it's a fuel that can never runs out. Okay, and we have a zero carbon emission. It promotes cleaner air and water. This is the cheapest form of electricity. Renewable energy creates new jobs. And examples for such renewable energy sources are solar, wind, falling water, heat of earth, plant materials, waves, ocean current, temperature difference in the ocean, and energy of the tides. Let me say the drawbacks. Disadvantages of renewable energy source. Higher capital cost, electricity production can be unreliable, and energy storage is reliable. See here, I am saying about the disadvantages in having the disadvantage in using the renewable energy source. My dear students, can you please tell me, though I am saying about the disadvantages of renewable energy source, why we people are stressing about the renewable energy source? Can any people say me? I'm in the current slide, I am focusing about the drawbacks in using the renewable energy source. Still, it has some drawback. We people are stressing about the utilization of renewable energy source. Why we are saying about the renewable energy source? We are stressing about the renewable energy source. Students? Okay. Okay, let me go to my PPT again. So, though we have some drawbacks like increase in the capital cost, electricity production which is unreliable, and the challenging in storing the energy storage, we have very important factor. This utilization of renewable energy sources, one which is not going to pollute the atmosphere. So this is which is going to be the one. This is a green source of energy protecting our earth, right? So that's why we peoples are focusing on the renewable energy. Next, in this next slide, I want to say about the importance of renewable energy. Next words. So then in this quote, I'm saying said by James Cameron, the nation that leads in renewable energy will be the nation that leads the world. Right? So because of this aspect, we people are promoting towards the renewable energy. Okay, the nation which leads in renewable energy is the one that lead the country. And my dear students and research scholars, the faculties, we have the responsibility to lead our country among the worldwide. So to lead our country worldwide, we have to concentrate on this renewable energy. That's why we are going through this renewable energy. Here is the statistics of the installed renewable energy capacity by the year 2024. So can you able to see that where our India is? Our India stands in the 4th place, generating 204.3 gigawatts of electricity production, energy production. So this is the statistics. So we can say that our India is going towards a leading country. So the first one is China, United States, Brazil. Next is India. So we can say that our India is progressing towards it. So with the extended work by our peoples, we can able to make our country to the first place. And it's our role, each and every person's role to promote our country to reach this first place. And next, I want to say about the applications of renewable energy in electrical vehicles. So just I'm saying about, I started my discussion by saying about the energy, and slowly I propagate to the renewable energy and non-renewable energy. I said about the importance of renewable energy, and now I'm connecting this renewable energy to the electrical vehicles. And in this inaugural function also, Dr. Arunkumar has said that you have received that more papers covering this renewable energy. I'm very happy towards it. So the applications of renewable energy in electrical vehicles are solar energy, wherein we have photovoltaic systems such as rooftop solar panels or solar canopies at charging station, converting sunlight into electricity for EV charging. The best example for this is by integrating this rooftop solar at charging station leads to great reduction in the electricity expenses. So we can able to greatly reduce the electrical expenses. A good example for that is a power installed it's a power station installed at Nadu. Next one is the wind energy. This generates electricity that can be fed into the grid and are used direct or at charging points. So in this, saying about this wind energy harvesting, we can able to harvest this wind energy both in onshore and offshore. Comparing to this onshore and offshore, this offshore wind energy seems to be the most effective one because it is more stronger because of two reasons. One, it is more stronger and it's more consistent, having more consistent winds. And next one is the hydropower. This hydropower stations are built where and all we have abundant of water resources which can be able to utilize the hydroelectric power. So this is one of the sources to generate the clean electricity for EV charging infrastructure. Next one is the bioenergy derived from organic materials which can power hybrid vehicles, offering a renewable alternative to traditional fuels. Next, let me say about the benefits. So what I said in the previous slide, I have connected renewable energy with EV. So what is the benefit? Why we have to connect this renewable energy with EV? Because we have various tremendous benefits. The main thing are environmental impact. So environmental impact is it reduces the greenhouse emissions and air pollutants. As it reduces the greenhouse emissions and air pollutants, it contributes to the cleaner air and combating to the climatic change. So we can, and you people can able to realize that our earth is now suffers greatly because of the climatic change. So we can able to compare towards it. Energy independence means it decreases reliance on imported fossil fuels, enhancing the national energy security. So which is very, very important. Next one is the economic advantages. The operation cost is greatly lowered for the EV owners because of the reduction in the fuel expenses and promoting the potential earnings from grid service. Next one is the grid stability. Smart charging and V2 vehicle to grid technologies came into existence, which helps to balance electrical supply and demand. So this will decrease the strain on the grid, particularly during the peak demand times. And next, I want to say about till this I have given introduction to the energy, renewable energy, connection of renewable energy with EV, and why we have to connect this renewable energy to EV. Now I want to say about the innovation in this way. So to start about the innovation in this renewable energy, I want to start with the quotes said by Brendan O'Brien. If you think that the internet has changed your life, think again. The Internet of Things is about to change all over again. So we all can sure accept that the internet has changed our life very, very great extensively. So if it's so, the Internet of Things is the one which is going to rule in the hereafter. So with this quotes, I'm going for the next part of my lecture. So here, once again, I want to remind that Sir has told that we have more papers towards this IoT, and I am also going to say about a few things about the IoT. So introduction to IoT. What does this IoT or Internet of Things means? It is the once again. Sorry, I'm very sorry. Sorry for the disturbance, interruption. So let me say about few things about IoT. So IoT or Internet of Things is a very, very, very familiar one nowadays. It's nothing but the networking of physical objects that connect electronics embedded within the architecture to communicate and sense the interactions among each other. Simply to say, this is nothing but the interconnectedness of physical devices such as appliances and vehicles, which is embedded by the sensors, software, and connectivity. Sensors is the one which is able to go into sense the physical variable, and software which is going to make the analysis, and connectivity is the one which is going to communicate with the end user, right? So some of the sensors, temperature sensor, image sensor, gyro sensor, obstacle sensor, RF sensor, IR sensor. There are so many sensors which came into existence. And let a small view of how this IoT has evolved. In 1982, we have a vending machine. This is the first glimpse of IoT, which is connected to the internet and to report its inventory and status, which paves the way for the remote monitoring. And so this IoT is not a new topic which is trending nowadays. This is a very, very older one. I'm here to say the travel of this IoT. In 1990, we have a toaster. This is an early IoT innovation. This is innovation. We have a toaster connected to the internet, remotely controlled, foreshadowing the convenience of smart home devices. So this is a basic for it. In 1999, it was coined by Kevin Ashton as Internet of Things, describing the interconnection of network of devices communicating and sharing data. In 2000, we have LG Smart Bridge. So LG Smart Bridge marked a breakthrough, enabling users to check and manage refrigerator and connected contents remotely. In 2004, the smartwatch, which you people, youngsters, are wearing because of so many features, was introduced in the year 2004 to the wearable tech realm, offering fitness tracking notifications on the go. We have so many features, hence you people are wearing it and preferring it. In 2004, we have smart iPhone. This became a game changer integrating IoT capabilities with apps. In 2009, we have the car testing. IoT entered the automotive industry, enhancing the vehicles with sensors and real-time diagnostics, performance monitoring, and remote sensing. And 2011, the smart TV comes into existence, brought IoT to the living room, enabling internet connectivity for streaming, app usage, and interactive content. In 2013, we have the Google Lens. Google showcased the IoT. And 2014, we have the most admirable thing of the kids, the Alexa. 2015, we have Tesla Autopilot. And 2015, we have smart cities, introduction of the IoT in smart cities. So what is the importance of IoT means? We have an improved efficiency, data-driven decision-making, cost saving, enhanced customer experience. Some of the technologies for IoT, sensors and actuators, connecting technologies like Bluetooth and all, cloud computing, big data analytics, security and privacy technologies. So I don't want to take so much time, so that's why I'm going speed up. I'm speed up in the session. I'm sorry. So next, the IoT applications, smart grids, energy saving, smart grids and energy saving, smart cities, smart homes, home automation, healthcare, earthquake detection, radiation detection, hazardous gas detection, smartphone detection, water flow monitoring, traffic monitoring, wearable smart doors, lock protection, robots, drones, healthcare applications and all. So this is the importance of IoT. See the growth of the IoT devices. In 2015, it's about 15.41 billions, and it slowly increased. And by current 2025, it reaches a great height of about 75.44 billions. So some of the applications of smart cities. Before this, my dears, are you people can able to listen? Yes. Hope it's so. Hope it's so. Hope it's so. So these are the somewhat of the applications of IoT in smart cities, smart parking, public safety, waste management, utility management, remote sensing, environmental sensing, remote public transport, smart traffic, life management, and all. Now, I have given an introduction already, but I just want to say it again. The emerge of EV vehicles. We know well why the EV vehicles emerge. So greatly to reduce the air pollution, which degrades the atmosphere. So this challenging issue can be reduced by the vehicular pollution. So thereby the electrical vehicle came into existence as an innovation step. And this are nothing but an high-tech machines which consist of a lot of data to have an optimum performance. Whenever by having optimal performance, we can able to have a better utilization with improved efficiency. Cost-effective one is the most important thing. This electric transportation is becoming an essential part of the global automotive industry, providing the environment, economic, and energy security benefits. So I'm just comparing these traditional EVs with IoT-based EVs. These EVs are limited to single vehicle, whereas it can't able to interact with the neighboring vehicles on the road or any other persons. This is about the traditional EV, right? That is that if suppose you want to communicate, in the sense the driver has to manually have to connect himself with the nearby atmosphere. So he has to manually charge their EVs if they need. Suppose if they need to use the public charging station. But with the help of IoT, with the help of a very good thing that called as a GPS, the EVs can now communicate with each other with the surrounding atmosphere. So this is a great advantage of IoT-based EV compared to that of the traditional EV. So now this IoT for what this IoT for electrical vehicle says. So in this, when this IoT technology is incorporated in the electrical vehicles, that is in the traditional electrical vehicles, we can able to have a monitoring of various performance parameters like speed, acceleration, mileage, battery management, charging, fault alert, predictive maintenance systems. Those people using this can able to know it well. The IoT plays a large role in monitoring these electrical vehicles. The IoT in electrical vehicles refers the integration. In the previous slide itself, I have told you that IoT is nothing but the interconnection of various sensors, software, and communication networks. So these are all integrated to create a connected EV system. And what does this IoT components has? It has a sensor. This is the simplified block diagram of the things what I have said so far. Sensors and actuators, which is given to the connectivity. We have various Zigbee technologies, Bluetooth, Wi-Fi and all. We have the IoT cloud. And again, next we get the IoT data analytics and data management. And finally, the analyzed data is given to the end user. This is smart city implementation. Nowadays, the government itself implementing the smart city technology. That is, the data is acquired from various remote places. These data are sensed because sensor is the main thing. Next, we have the interface, and then we have the end user. So the sensors, the data, the physical variables are sensed, and by the sensor, by means of the by the routers, then it is by the actuators, and then it is given to the physical device for analyzing, where we have various real-time analysis, thresholds, statistics. The analysis is then, and then it is given to the end user for various applications like meeting, transportation, lighting, and all, location, well-being, various, that is various applications of the IoT applications are smart applications. We can group in any way. This is a one pictorial view of the usage of IoT in electrical vehicle. Here we can able to see a person, is forcing to open a car. So that is be the theft of a vehicle, theft of the vehicle. So once you do this one, the sensor alerts the owner that a person is making forcing to open. So this signal is sent by the sensor. It is given to the cloud computing and is given to the person, to the owner who is situated at remote place. So from that you can able to he can able to have the knowledge that that his car has been is forced to damage. So this is the main application of the IoT in electrical vehicles, the security. So the advantages in general, this is we have the ability to monitor, analyze the data by connecting to the cloud. Collection and analysis of data of various sensors such as speed and location by means of GPS can be done. The data can be used to improve the performance of the car, detect, diagnose malfunctions, optimize the driving experience. The IoT enabled EV technologies are more efficient, safe, sustainable energy grid, resulting in reduced energy consumption and carbon emission. So this is one, this is a thing challenging for our EEE peoples to promote the sustainable energy grid, to reduce the energy consumption and carbon emission. This is going to be the key factors, which is most challenging one. So these are the various IoT components. I already have told it. Then there's our telematic devices, sensor, communicate devices, dash cameras, and all. Some of the IoT applications. So IoT in electrical vehicle is a very, very, very broad topic wherein we can have various applications like vehicle connectivity, energy management, EV charging management, battery management, predictive maintenance, fleet management, personalized user experience. So let me say a few talks about, in particular, various applications are there. In this, as time is concerned, I can't able to say more. I want to say about a particular thing about the few things about the fleet management. So what is fleet management in the sense to have to promote the pollution, to promote have a green energy in the world. Nowadays, the countries itself, the government itself, taking more effective work, utilizing the electrical vehicle. So thereby, the fleet management, or is nothing but the management owned by the fleet owners. Fleet owners, in the sense, some group of cars or electrical cars that is owned privately or by some sectors can be managed very effectively. That is called as a electrical vehicle fleet management, and this can be done by means of a IoT. This fleet management system for electrical vehicle utilizes sensors, data analytics to track and manage EV fleets more efficiently. So this is a software solution designed to optimize the efficiency, maintenance, and usage of fleet of electrical vehicles, and thereby we can able to improve the efficiency. As I said, IoT is nothing but the interconnection of various sensors and devices. This is also an interconnection of sensors and devices embedded in the vehicles for capturing the data. Depending upon the requirements of IoT, it helps to track and monitor the vehicles at appropriate locations, and we can able to have the relevant information. So this is a pictorial view of an electrical vehicle wherein we have various parts in the EV vehicle. The various parts are the rear camera, tire pressure, fuel, driver behavior, various things, panic button, front camera, and the things which are variables or which are monitored are the temperature, the GPS, that is a location, tachograph, the messaging, the communication, the things, the relevant information, because we want to communicate to the owner or the charging infrastructure, where the availability of fuel and all. So then energy codes, job dispatching and all. So this is a pictorial view of the various parameters and the various devices provided in the electrical vehicle, which is connected for IoT for better effectiveness and to improve the efficiency. So the technologies for and various, we have apart from IoT, we have various technologies like AI, machine learning and all. But here I'm saying about the IoT. Like this, we have the introduction of IoT, the ML, and nowadays these things are all pairing together with EV for better sustainability. That is a pairing of AI, machine learning, IoT, or a part for better performance, improved performance. So these technologies have RFID, nothing but the radio frequency identification. This is used for asset tracking and identification. Next is GPS, nothing but the global positioning system. This provides precise location of data for vehicles, enabling real-time tracking and remote optimization. Next is OBD, nothing but onboard or diagnosis. So this provides access to various data, including engine performance, fuel consumption, and maintenance fuels. So these things, these RFID, GPS, and OBD put together makes the effectiveness of electrical vehicle with the help of IoT in a very so the innovation and collaboration are a key to overcome the barriers. That's why this sort of international conferences or various researchers are paving the way for promoting the innovation in this renewable energy field. With this continuous effort, we can have a transition to the renewable, to the sustainable, secure, and equitable energy future. With this thing, again, I want to end up with the quotes which I said in the earlier. The future is a green energy again and again, sustainability and renewable energy set by renewable energy, said by Arnold. With this quotes, I want to end up the session, and I wish to express my sincere thanks because another speaker is there, so I want to end up the session. With this, I would like to end up the session. Thanks to all the faculties, research scholars, students for your patience listening. I wish to express my heartiest thanks to the management principal, HOD of EEE Department of JP College of Engineering for arranging this nice event. And also, I would like to express my sincere thanks to Muhammad Ali, sir, Professor of EEE Department, for inviting me to deliver this keynote speech. Thank you, sir. Thank you, everyone. Best wishes for the grand success of this international conference. Thank you, sir. Handovering my session to the Arun Srinivas, sir. Ma'am, I'm audible. Thank you all.
Thank you, ma'am. Thank you. Thank you, ma'am. Thank you. Thank you, ma'am.
Thank you, sir. Thank you, dear participants.
exam.
Arun sir. Sir, am I audible, sir? Arun sir. Arun sir, have you started? Arun sir. Arun sir. Arunkumar sir. Arunkumar sir. Am I audible, sir? मीट लड़कियां अनुराग रेस मीट लड़कियां मीट लड़के गूगल मीट लड़कियां नहीं ले आओ Sir, am I audible, sir? Arunkumar, sir, can you hear me, sir? Arunkumar, sir.
நான் பேச இங்க கேக்குதா? கேக்கு. நான் பேச கேக்குதா? இப்பதான் கேட்டுச்சு. கேட்டு.
Arunkumar, sir. Arunkumar, sir. கேக்குதா? Sir, your video is visible. Arunkumar, sir. Hello, sir. Am I audible, sir? Now we are. Ipo voice கேக்கு, sir. You can proceed.
So, thank you for everyone. So, good morning. This is Dr. Arun from Taiwan. Is it visible my screen, ma'am? Hello?
Yes, sir. Visible, sir.
Yes, sir. Visible and your voice is audible, sir.
Okay. So, thank you for everyone. So, first of all, I would like to thank Jayalakshmi ma'am inviting as part of the international conference on recent challenges on EEE. So, let me introduce myself. This is Dr. Arun from Taiwan. So, currently I'm working as a professor in National Yunlin University, Taiwan. So, it will be great pleasure to present my talk on green energy with the AI trends and as well as future directions. So I'm an AI expert. At the same time, my research field is more related to sustainable computing. So as you know, the sustainable computing is more related to addressing the people problems and as well as environmental problems. And where my team is also working on related to the green energy. And as you are aware, like the green energy is more emphasizing on, generating the energy from the natural sources, where you try to classify the green energy as a part of the renewable energy. It may be classified under solar energy. You might be heard about solar energy, or you might be heard about wind energy, or you may be heard about the hydropower, or you may be heard about biomass and so on. So these are all the energy is a part of green energy. But today I'm going to cover how the AI techniques is going to impact on green energy, and what are the research directions we can work on, and what is the impact of AI towards the green energy to address various challenges in green energy. So is it my screen is moving, ma'am? Is it my screen is moving? Hello?
No, sir. Screen is not moving, sir.
Now moving, sir.
Now it's moved, sir.
Is it moving now?
Yes, sir.
Okay. So, this is about me. Before I came to Taiwan, I was in a different capacity in Taiwan. And this is the overall outline of my presentation. So, as you know, the green energy is the various energy sector benefiting from AI, and how the AI is going to be impact on renewable energy power plants, and what are the key trends for AI in green energy, and what are the case studies and the challenges towards how we are trying to address AI for green energy and so on. You can see how the AI is making the bigger impact in the current market from 2024 and to predict 2034. You can see the AI and renewable energy market is expected to be, from 16 billion to 158 billion. We expected that because of most of the countries are more relies on green energy because of the natural resources are, very high impact in most of the countries. So they try to impact on, specifically when we consider India, China, Southeast Asia, investing heavily towards the AI techniques for renewable energy because of we make it as a smart systems, or we make it as a smart automation. When we are talking about the automation, again, the AI is going to be really coming to the picture. So today's talk, I'm going to briefly cover why we need AI in terms of, addressing towards the various challenges of renewable energy. So you can see that how the AI is going to be a bigger impact in renewable energy market from 2024 to 2034. So you can see the chart shows the Asia Pacific dominates the AI market in renewable energy, especially India, China, and Indonesia, whereas the Vietnam and so most of the countries, currently focusing on renewable energy instead of focusing on the traditional energy because of the natural resources are, being a bigger impact towards the renewable energy. So the growing demand of the electricity because of the population is higher. At the same time, we cannot always rely on the traditional power. Instead, the government is have an initiative to move ahead towards the renewable energy. And again, in this context, the AI technology and helps to boost adaptation, scale solutions across the various regions. And I think everybody know like AI techniques, artificial intelligence, and artificial intelligence. When we are talking about AI, we have a various methods and we have a various techniques. We have algorithms, we have a machine learning, and everybody we are talking about the deep learning and so on. So majorly the AI can help us to make a predictive forecasting. So what is currently, and based on the past data, we try to train our machine, and we can able to predict our future. So kind of predictive forecasting to improve the energy managements. And similarly for optimizing the operations, when we are talking about the green energy, we are trying to have a various impact. As you know, like we are trying to reducing our CO2 emissions. At the same time, the operational cost, is trying to minimize through AI. And because of the automation, we can able to reduce the number of mans to be involved in respective process. And because of most of the countries heavily relies on human power, and whereas the AI can be replacing the human intelligence into be a machine intelligence, so that can be reducing the amount of operational cost. So at the same time, the AI techniques can be help us to make a real-time monitoring and something we call it as a predictive maintenance. So we can able to predict, our future and what is the demand of the energy and how the AI techniques, these AI techniques generally we are trying to use in green energy sector for the purpose of optimizing the energy production and improving the energy storage. Say for example, in the battery. And the carbon emissions and energy efficiency when we are talking about smart buildings and so on. So you can see how the AI systems works beyond the scenes. As you know, like the AI workflow, like everybody nowadays you are talking about ChatGPT and the large language models and the various interfaces. And this diagram shows the AI workflow and how the LLM is being used in as a part of AI with respect to the predictive maintenance and smart grid management and so on. So generally, when we are talking about the AI in a different sector in sustainable energy, where we call it as a smart grid management. Under the smart grid management, we can able to see the load forecasting, at the same time energy demand, and of course, like we can able to minimize the amount of energy to be wasted to enhancing the grid readability, and also we can have optimization of the grids. So because of the architecture supports the AI in different sectors, so including renewable energy. And recently, everybody, we heard about smart vehicles, electronic vehicles. So again, the electronic vehicles, the integration of the AI, kind of grid demand and as well as renewable availability, something we call it as where the EV electric vehicle and smart energy, back to the grids, whereas we try to enable vehicle to grid technologies. So we can say like the overview of how the AI will be used in our renewable energy. And you can see we are using the ML machine learning techniques. So generally, when we are talking about AI for optimizing the energy productions, so AI can help to, kind of demand and according to the weather, it can help to adjust our energy production. As you know, the energy when we are talking about the green energy, like say we can have a PV solar energy, like kind of we try to generating energy through solar panels, and subsequently we can use our AI techniques for demand response and energy flow and avoiding the various backouts and kind of predictive maintenance we can able to generate. At the same time, the renewable energy forecasting. And this slide is generally how the AI and as well as machine learning can be applied in different areas, such as to optimizing the energy production and demanding the response in order to adjusting our energy flow. So another important usage of AI in terms of renewable energy forecasting, where how the AI can predict how much solar and wind energy being available and to have various options for energy storage managements. So how the AI is kind of renewable energy power plants. So as I told you, solar energy means we are trying to generating the power in sunlight, whereas you can see the wind energy, like we can have a wind turbines, and whereas hydropowers where we can able to generate through kind of water flow, heavy water flow in rivers and sea and so on, and whereas the biomass can be able to generate through the wastages, crop wastages and animal wastages. It can be generated through biomass, and you can see the how the AI can be helps to manage more energy in a smarter manner. So this image shows how we try to use different energy sources such as solar, wind, biomass, and geothermal, all connected in one systems. Right? Nowadays, the government is not relies on one sector. It can be relies on multiple energy sources because of the usage of energy in a higher volume and demand of energy in a huge context. So when we consider about the AI in renewable energy power plants, we always relies on smart grid systems and how the AI can help us and how the electricity from those sources being shared among the users more effectively. And you can see the next slide is about AI in renewable energy. We can say the biomass. It breaks into three key stages how the AI is improving the energy efficiency. So here we can say how the machine learning can be supports for bioenergy, starting from improving the properties and forecasting, and similarly for operating conditions of biofuel and so on. So how the AI can be help us to improve the production process. That is the most important thing. Whenever we try to use AI, it can be improving the overall efficiency of the process, such as the biomass power energy is more efficient and as well as eco-friendly and so on. So when we consider the AI in renewable energy, we can say hydropower. The hydropower, again, how the AI can forecasting the river water levels using the rainfall data, at the same time the hydrology models. In the hydrology power plants, how the future water can be flow is the key deciding how much energy can be generated, how the electricity can be generated. So using the AI in forecasting the hydropower, like kind of past rainfall and water level data into train our AI model, and how the AI can be predicted the future water levels using the weather forecast, and how the AI can help us to optimizing the turbine operations and avoiding the water flows. So here we can see the based on the periodical data, the machine learning can help us, to train past data, and it can be predicting the future demand can be done more effectively. So one of the another techniques we call it as a geothermal, and this is something called AI powered heat modeling geothermal systems. And here AI can help us to model and underground the heat flow and as well as recovery. And we can see the simulation of the heat movement geothermal reservoir, and whereas AI can be modeled to total heat and as well as heat loss and recovery efficiency. So these insights can, by using the AI, can be able to predict the heat behavior, the The most important thing is heat behavior and how the geothermal plants can be operate more efficiently at the same time reducing the cost at the same time, like how the error of drilling and can be handled. It is most important. The AI can be reducing the amount of time to be to make the process more effectively. So our next thing is like we can have AI in renewable energy wind turbines. So you can see the AI-based predictive maintenance in wind turbines. The AI can be monitor the physical conditions. So that is the most important thing. Like kind of analyzing the blade condition using camera feeds. So you can see the wind turbine is keep, rotating. At the same time, how the predictive maintenance of the wind turbines can be on the basis of the blade conditions using the camera feeds. And here, maybe the previous speaker is talking about the Internet of Things, IoT, again, how the edge computing again can be enables the real-time fault detection. So fault detection, you can see the blade is not running properly, then the appropriate wind, the energy may not be generated. And here we try to use our AI with edge computing can help us to detect our fault more effectively in a real time, such as AI can monitor the physical condition of the wind turbine blades, whereas it can be a waterproof camera and sense the real-time video, where it can be the edge AI computer can detect the cracks or even damage, and maybe something like we try to predict the faults in advance, something like a predictive maintenance. AI predictive maintenance, maybe if we try to predict the certain faults in advance, maybe we can able to kind of avoiding the major hazards to be happen or major damages to be happen in the wind turbine blades. And here we can say that we can have a central dashboard where it is allows to maintain the maintenance team to take an actions before the failures happen. So something like we are improving the safety and saving the time and saving the cost. More relies on AI techniques can able to give the message to the technicians before breakdown or failure to be happen. So one of the very famous techniques in almost all the world, where we call as a renewable energy in solar PV. So solar PV in the installation cost is very less. At the same time, generating the energy like kind of very feasible way we try to generate our renewable energy. Like you can say like the forecasting, again the AI techniques, how it is making a bigger role in terms of solar PV, like how the AI models such as deep neural networks and other models can able to train the data using the solar radiation and the module temperature and as well as ambient temperature. So whereas we try to use the various AI techniques such as exponential model, moving average, can try to improving the overall accuracy of the model. So not only these techniques, we have a couple of techniques, but here I'm trying to focusing on some of the techniques, some of the AI techniques, how it is making a bigger role with respect to the optimization of the solar PV. So the key trends in AI towards the energy case, such as we can say the four main trends where the AI is transforming the energy sectors. One is the energy forecasting, like how the AI is trying to predict the future energy demand. That is the most important thing. So future energy demand of solar, future energy demand of wind. So this will help us to bring a better planning and as well as reducing the wastage of energy. And whereas the second one is we call it as a smart grids. This makes us the electricity network in a smarter way. and AI can help us to managing the power flow and detect the faults and balance the supply and demand. And third one is we call it as energy storage. Everybody know the battery. So the benefits from AI through smart charging. Again, everybody know like smart charging, duration of your battery, that is lifespan, and efficient usage of battery, and all part of AI related systems. And the final one, we have electric vehicles and how we are trying to use AI for battery monitoring and something like a predictive maintenance or optimizing the charging based on the grid conditions. All key trends of AI being used in energy related cases. And one of the thing is like we call it as energy forecasting. So it is on the basis of numeric weather forecast and number of weather forecast, and we try to detect from weather data from the various historical data for the production. So this image shows how the AI and the statistical models can able to use for renewable energy production forecasting. Say for an example, next 10 days, how much energy to be required to utilize. So that can be able to do like kind of phase and as well as other statistical models. So with respect to the energy forecasting, how do we use AI in terms of predict the future energy demand and like kind of ARX model and the power curves, all part of how AI PV based power plants such as AI can help us these curves more efficient manner. You can see the energy forecasting, and again the AI is making a bigger role, and this charts can able to identify how the AI can forecasting the energy prices and analyzing the historical data and the patterns, can able to see the top growth of future prices. You can see the blue shaded arrows areas shows the uncertainty, and uncertainty can meaning of how the confident of the system in those predictions. And similarly, those forecasts can help the energy providers in order to identify the better conditions for decisions, such as when we talk about solar energy or kind of reduce the usage of higher cost periods. So this is something like AI is smartly automated. Sometimes we are in a huge demand, and maybe we can able to put the higher cost to the users. In Taiwan, like if the energy usage is high, then the charges also might be high. It's kind of dynamic pricing will be given to the consumers. It's a key point of without AI, it is not at all possible to do the dynamic pricing. And because of the based on the energy usage, we can able to give the pricing of the users. So the blue shading can shows the uncertainty bands and how the confidence levels for future predictions. And here's smart grid decisions can be able to identify the energy prediction, storage, and as well as usage timings. So when we are talking about AI in key trends in energy management, one of the major area is smart grids, and smart grids combining the connected energy sources. You mean the connected energy in terms of solar, hydropower, wind power, everything is connected together and storing through real-time sensors. Say for an example, we call it as a AI-powered control center, whereas the AI algorithms can able to analyze the energy flow and as well as detect the several issues. And similarly for efficient distribution and sensors and as well as communication networks can able to do with respect to these key trends of AI and as well as smart grid management systems. So when we are talking about these smart grids, it's a kind of modern smart grid environments. Why we need AI again? So here AI can help us to predict how much energy to be needed and how much is generated, what is needed and what is generated. It is most important thing to identify such as the sources, energy sources from different thing, such as the solar or such as the wind energy and so on, and how it is being generated, how it is being transmitted, and how it is being distributed among the consumers. That is the most important thing. So here the AI is making a bigger role for improving how the electricity is being produced among the sources. How much energy is produced. Say in future, say next 10 days we need a more energy based on the historical data. Say if it is raining and if it is a winter, then we don't have a much energy to be required. So AI system can help us to give a recommendation to the recommendation to the respective authority or decision makers, can help us to make decisions. So the key trends with respect to the AI in terms of energy storage, we call it as a batteries. So there are major features. We call it as a sustainable battery. Sustainable battery, again, how long the lifespan of the battery, at the same time how the battery being kind of reused and in a sustainable kind of ecosystems. And we have the kind of how the AI is going to be shaping the future energy storage in green energy systems, such as the sustainable, affordable, and as well as safer. That is the most important thing. How the AI is going to be a key role for optimizing the materials, how the AI is optimizing the battery, and how the AI is going to be optimizing the performance of the battery, and how the AI is going to be reducing the overall cost, and how the AI is going to be benefits through smart charging and the efficient usage of battery. And in maybe the future, the batteries may be expected kind of higher energy density and faster charging. Even nowadays, everybody expecting that your mobile batteries should be charged very lesser amount of time, at the same time longer lifespan of the battery. And how those batteries are environmental friendly is the most important thing when we are considering the AI for key trends for storing the kind of energy storage for the batteries. So here I can show the kind of new battery materials by how the AI can significantly speed up the process, especially in materials and discovery and as well as automated process. You see the AI could sustainably aggregate environmental for material discovery and kind of production efficiency to reducing the cost. At the same time, like how much battery must still overcome the kind of automated testing and so on. So the next thing is like how the AI is going to be energy storage, and we can say how do we make the energy storage, make the batteries to be a long laster for the smarter maintenance and saving the energy cost, and helps to avoid the power outages and improving the solar and wind to up and downs, and enables the flexible energy storage and so on. You can see here the usage of AI in terms of a real-time monitoring, and where we can see it tracks the battery performance into 24/7, and predictive maintenance can detect the battery issues, and smart charging and energy forecasting and peak saving, reducing the power usage during the high demand times. So these are all the area where we could use the AI for smart energies. So the key trends of AI in terms of energy, the role of electric vehicles, how the AI is going to be a bigger role for energy battery aging estimation, at the same time boost the material recovery through intelligent separations. You can see the AI-based aging estimation and how the AI can support the batteries beyond just powering the electric vehicles. You can see in India, we have a very lesser electric vehicles. While I'm in Taiwan, the most of the cars are electric vehicles. And here we don't have any problem of energy usages, the sufficient amount of energy. But whereas India is highly populated, electric vehicles, the usage of electric vehicles is very tough because of we have a shortage in energy sources. So here you can see the key trends of AI using the electric vehicles, the AI-based diagnostics, how we can simply true and false with respect to the fault checks and predict the faults early, and enables preventing actions to reducing the power instead of sudden shutdowns, and improving the safety and reliability and the battery lifespan. So you can see the traditional systems can only detect the problem when it happens, then shut down the battery. But we can see we can use AI, can predict the faults before it can be occur, and analyzing the detailed battery in a current over time. So with respect to the AI, can detect earlier, for example, reducing the power instead of cutting it completely, and improve the safety and prevents the breakdown and gives the better performance. So the next one, we have benefits of AI in energy sectors. We can use AI in a different aspect, something like a defect classification, and we have a production line optimization, and we have electric grid management. So the major impact in terms of a smart planning and as well as resource optimization. So here AI is playing a key role for transforming and how we generate and as well as managing the optimize the energy. For example, in operations, AI powered drones used for fault detections. And similarly, when we can use the machine learning models, can help to predict the failures in the equipments. And at the same time, you can see where we are trying to improve the reliability and as well as can able to detect the fault areas in the, say, like in the solar panel, we can able to detect the fault areas, and how the AI is making a bigger role, improve the overall energy, and how the AI can be reducing the amount of cost, and helps to integrate whole energy systems are more smarter and as well as in a more resilient manner. So one of the major case studies, we can see the Tesla virtual power plant. So this slide is showing how the Tesla virtual power plant systems, it connects like batteries and solar power systems are integrated together and to form a decentralized power network. And how the AI is going to be a unified system, and where how we are trying to managing the stored solar energy from homes and feed back to the electric grids during the demands. So it's something like kind of vice versa way we try to managing the stored energy to the homes, at the same time feed it back to the electric grids during the high demand. It's also one of the case study with respect to the Tesla virtual power plant. It's all part of renewable energy systems. And another case study, we can see like how the AI is going to be used in Tesla virtual power plant, because of the AI is again can be able to supports the grid management system and can be reducing the overall electricity power and optimizing the battery charging, and at the same time it is something like how the smart energy storage can be benefits for both households and as well as wind energy systems. Kind of how do we integrate one or more renewable energy sources? Say for an example here, the solar PV is going to be integrated with some other renewable energy systems, and how we try to managing our power plant more effectively. So you can see in our partner, we have a University of Indonesia. They are majorly, focusing on solar energy systems. So here, how they have generated the virtual power plant by Eco Wall in Indonesia. So this approach supports grids and lowers electricity, and where we can see the Eco Wall is being developed by University of Indonesia. This picture is showing that where it's our partner, where they're trying to generate the Eco Wall, and it is act as a virtual power plant by connecting the batteries with the solar PV systems and the national utility grids. Whereas the major features such as smart energy storage and real-time monitoring and energy independence are all reflecting towards the green infrastructure solution. So this is something like we call as a Eco Wall, and it's kind of virtual power plants. This is we built in the University of Indonesia in Jakarta, Indonesia. And the benefits of the virtual power plant, you can see it can be reducing the amount of cost, and where the lowering the electricity bills using the solar PV and the peak periods in order to minimizing the cost. And here we can see the virtual power plants can connect the small energy sources such as solar panels and as well as battery and kind of smart systems. So this setup can be reducing the amount of electricity, and during the expensive peak hours also improves the overall grid stability by reducing the risk of backouts and as well as lowering the resilience in respective fuel independence. So here the virtual power plants can be, it's an environmental impact. So the maximizing the usage of energy by reducing the carbon footprints. CO2 emissions is the most important thing. Every country is, investing a lot of money for renewable sources, and it's also one of the major area. And they can be monitoring the health, and from the health wise also, we also offered renewable energy can offer major benefits to the people. So again, it's our research how the AI powered drones for solar power monitoring. So this research, we try to use the drones in order to identify the defects in the solar panel, such as we use our thermal images can be detecting the faults such as hot spots, cracks, and dirt accumulation. Also, we try to use the AI algorithms here with respect to the analyzing the amount of faults being occurred and how much energy being generated, and we can have a control room can be alerting the real-time maintenance. If something is going to be a bigger fault, it can be avoided well in advance. That we call as a predictive maintenance can able to do it. So other case studies such as AI powered drones for solar panel monitoring. So it may be used AI techniques for automated inspections. We can able to detect some of the faults and how the drones can embed cameras, and how the camera can take the pictures and try to analyzing the certain faults. Either the fault may be due to the dust or either other factors. Then we could give an appropriate solutions to the system designer. And where we can see the thermal imaging detection can identify the faulty and as well as overheated solar cells by thermal cameras, and also can be saves the amount of time and improve the overall energy and supports our predictive maintenance. So these are all the major case studies when we are talking about AI powered drones and solar powered PV. And other challenges when we are talking about AI and renewable energy and other things like data security, how we are trying to protecting our operational data, and how the privacy aspect to be handled, and it's also major thing. But it needs a strong data protection because of that setup is expensive. So many teams they lack of people both AI and as well as energy skill, and how the privacy and security aspects is one of the major challenges of AI in renewable energy aspect. And the challenge is how do we make our data to be a more quality in terms of incomplete, in order to reduce the incomplete and noisy data. It can be reducing the AI prediction accuracy prediction, and how the limited historical data affecting the forecasting model. So these are all the limitations when we are talking about to train our AI model in order to based on the historical data in order to predicting our future aspects. So duplicate data, incomplete information, and something like data inconsistency and invalid data, all part of kind of how the census data might be incomplete, noisy, and too slow. So inconsistent data formats from different sources can be confuse the model. At the same time, historical data might not be able to reach enough to accurate forecasting, because of your data should be a consistent data and your historical data should be a complete one, so that we can be able to train our model more effectively. And these data limitations can be affecting the everything about power prediction and as well as fault detections. You can see the challenges with respect to the kind of AI powered energy management system. And another thing is one of the gray area is like cyber security, and how the cyber threats for stealing out, how the energy systems are deeply connected through the digital network, and how the AI powered energy management system are effectively handled. It's a part, again, one of the bigger challenges. That's why the cyber security is essential to protect the smart energy infrastructure. So everybody, various threats as a part of the cyber security aspect. So another challenges like kind of dual role for AI in energy and as well as security management, and how the energy management system is powered by AI and handles the energy process, such as can be able to predict the shortage of the energy, at the same time improving the operational efficiency, and how we improving the overall security process of monitoring calculates the reliability and detecting the cyber threats before the damage to be occurred, and also can and everybody we are majorly focusing more efficient, at the same time secured way to prevent such cyber threats and mitigating the various security aspect as a part of the energy management systems. So the future directions may be like a stronger data governance and cyber tech security aspect need to be more focused, and the cross-disciplinary collaboration, bringing out the AI towards the energy. Nowadays AI is applying in almost in all the areas, but the energy systems, again, the future development of AI in renewable energy requires strong data governance, ensuring the safe and ethical data sharing, especially the system became more connected, and also the involving the AI professional security aspects and the policy makers to train the AI skilled. And the conclusion and how the AI being for the sustainable future, when we are talking about and AI in renewable energy sources towards the sustainable development goals. So we have various sustainable goals under this, when we are talking about the key areas towards the sustainable future of the energy, sustainable goal number 7, that is affordable energy and clean energy. And 9, we have industry innovation infrastructure. These are all the aspects is more focused on renewable energy. And we have 13 is the climate action. Again, it is directly impact to the sustainable energy. And the partnership goals, again, it is 17, It is also part of collaboration between governments and the researchers and as well as industry. And whereas the affordable and clean energy, the AI boosts the clean energy efficiency and supports the green infrastructure. Whereas the SDG 9, whereas the green energy infrastructure, again, AI is going to be solving the various challenges and as well as contributing the various sustainable development goals. And the kind of summary, like the AI is going to be transforming the green energy by improving the forecasting, and majorly like the key application areas, solar PV, wind turbines, and biomass, and so on. Also, I talk about smart grids, how the electric vehicles being integrated as a part of AI, and also the data security and cyber security aspect. We still facing the various challenges while we are integrating the AI towards the renewable energy systems, and subsequently how the AI being aligned with the various sustainable development goals and energy transitions remain sustainable and as well as inclusive. So thank you for listening, and any queries, please let me know. Thank you so much for the organizers for giving me the opportunity to deliver the talk as part of this international conference on recent challenges. Thank you so much.
Thank you so much, sir. We're really happy. Today, we learned many more applications with you, because of you, in the artificial intelligence and the renewable energy system. So for your valuable time and knowledge and in-depth knowledge of the artificial intelligence will really help our students and as well as the staff members for stepping towards the future, sir. Thank you so much, sir.
Thank you so much. Thank you for listening, and thank you for for the good conference and learning.
Thank you, Professor. Thank you. So let me step in the another path. No one who achieves success acknowledges the help of others. This time, on our department assistant professor, Mr. T. Manoj Kumar, for deliver the vote of thanks.
Good afternoon, everyone. It is my privilege and honor to deliver the vote of thanks at the conclusion of today's sections of the 5th International Conference on Recent Challenges in Electrical and Electronics Engineering. First and foremost, we honor our founder chairman, Reverend Father Dr. J. Arulraj. His enduring vision and blessings continue to illuminate our path and inspire our pursuit of excellence. To our respected administrator, Reverend Sister Hamlet, thank you for your unwavering support and inspirational leadership in nurturing a culture of innovation within our institution. Thank you, Sister. And a heartfelt thank to our esteemed principal, Dr. Rajkumar sir, for your constant encouragement and unwavering support, which have been instrumental in making this conference a reality. Thank you, sir. We are deeply grateful to our distinguished keynote speakers, Dr.S. Malathi, ma'am, and Dr. Arunkumar Sangaiah sir, for sharing their valuable knowledge and insights. Your contributions have greatly enhanced this event. Thank you, sir, and thank you, ma'am. Our sincere thanks to the jury member, Dr. S. Kumar, for your time, expertise, and thoughtful evaluations of the research paper presented. Your presence has elevated the quality of this conference. Thank you, sir. To the heads of the departments, we appreciated your continued support and collaborative spirit that emphasizes the interdisciplinary nature of this event. And my dear faculty colleagues, thank you for your commitment and hard work and behind the scenes efforts that made today a success. And finally, to all participants and students, thank you for your enthusiastic involvement. Your active engagement ensures that this conference remains a meaningful dialogue, learning, and growth platform. Once again, thank you all for your presence and contribution. Thank you all.
Thank you, Manoj sir, for your wonderful thanks consultation to us. So now the presentation will start as per the paper presentation schedule. Batch 1 and batch 2 have 2 different links. So kindly join the links as per respective badges, and your reviewer is also present in the link. So kindly start your presentation. Thank you all.